Hello friends. So this video we'll discuss about the thumb rule for performance optimization. So let's say if the chef is working and let's say in the restaurant if we have more orders, okay, than the number of chefs, and if we have less order and if we have so many chefs, okay. So what will happen in that case we will going to discuss in this video. And let's say here what we will see is we will dividing the task, whatever the task is. Let's say if we have to prepare a biryani or a kheer, okay. So preparing a meal for 100 people is a task because it will take time, so we will divide the task of making kheer or biryani in such a format that at least few people can be served, okay, and other people can wait. uh, Instead of boiling the or preparing the one big biryani, okay, in 3-4 hours for 100 people, it is better to divide the biryani, okay, or a kheer, or preparing in such a way that at least some people can eat and rest people can, obviously they can wait, okay, for the next order. So in this video we're going to work on this. I mean we'll discuss on that. And for the first thing is the number of partition greater than the executor. The same way, the number of partition means number of orders in the restaurant is greater than the number of chefs we have, okay, and it's a vice versa. Then we will going to discuss about the persist, memory only, disk only, memory only serialization, memory and disk serialization, memory and disk 2 of heap representation, okay. So let's imagine if you are a chef and you're a manager and you have hired 10 chefs, okay, in a restaurant. You are a manager and you're giving salaries to all the people, but there is only one, but there is only one order that is coming in the restaurant, and nine chefs are preparing one order, okay, serving one order. It's a very expensive, right? It's um so that way the restaurant cannot run, it cannot be made profitable. Okay, so something has to be done to make it profitable. Okay, either we need to increase the order or we have to decrease the number of chefs, right? So now we'll discuss about we will see here what is the use of cache and persist, okay, in this video. So basically, let's imagine that we are running a very smooth restaurant, okay, and whenever we talk about the cache, we'll talk about the fridge, okay. So cache is nothing but your fridge in a home. So the concept is why we are saying it as a fridge, because see, every time if you need something, you cannot go back to the restaurant or go back to the grocery store to buy few items, okay. For each and every item you cannot do that. Let's say if you want to prepare some gravy or biryani, okay, so there are many components, many raw materials that it needed to make the biryani, okay. So let's say if you need rice, if you need salt, so you won't go every time, okay, for every raw material to prepare the dish, prepare the biryani. So what we'll do is we'll store every item, or the basic necessary items. We will store it temporarily in the fridge, okay, so that next time if we need it, we will easily take it from the fridge instead of going back to the restaurant every time, or the going back to the grocery store every time. Yeah, so that's the basic use of the cache, okay. So make it readily available is what the need of the cache. It's just like a fridge in a home, correct. And um and let's suppose if you have a restaurant, if you are in restaurant and preparing a dish, okay, as a point of chef, and one person, if a chef need a butter, okay, and let's say if thousands of chefs are working in a restaurant, and one chef need butter, one other chef need sugar, and some maybe some other item. So how it will going to work? For everything, for every other item, he won't go to store, okay, grocery store, to bring the item. So he will buy the things in a bulk and store it somewhere in a cache, okay, which is very near to the kitchen, okay, just like a fridge, right? So the difference between the cache and the persist is, the cache is a very big set, and persist a very big set, and cache is a small subset of the persist. Okay, so cache is a subset and persist is a superset, right? So fridge is a cache, and persist is your superstore or your grocery store, right? Or you can say your go down, right? So if you're not storing in a fridge, where else you can store? So which is nearby to your restaurant? It could be your go down, okay, go down, or temporary storage near to your restaurant, right? So there you can store. So it is working as it is using the same concept. Memory only is your fridge, disk only is your um, go down, okay. Some things you are storing in memory only. And serialization is like your packing, okay. So let's say if something need to be operated in particular temperature, right, or maybe stored in some particular temperature, so you need a box of that thing, and it is just similar to that. So memory is your fridge, memory only serialization. So in the fridge you have one container which is self operated by some temperature, so it's the same thing. And memory and disk serialization is the same thing, fridge and your go down with the packaging of few items, okay. um, then you have this. So how you will going to do that in the Spark? You have to write this storage level, okay. In the storage level you will do true false, okay, whatever the scenarios you have, whatever you want. So if you want memory only, you will put true, rest other thing will be false, okay. And replication is equal to 1 means, so let's say for each data frames, okay, or for each data you can have many replicas. So if you lost one set of data, you have the other data to store, to work with, okay. um yeah. It's similar to, like, if you are if something in a restaurant, if something got rotten, okay, if it's a waste, okay, then you can use the other side to work with. It's the same thing. So I think I hope you like this video. Yeah, thank you.